Hello and welcome back to the Frame Channel. Railway tracks buckling under the heat of the sun is a centuries-old problem that causes thousands of railway journey delays each year. Steel rail tracks usually expand in hot weather, sometimes causing the tracks to curve slightly or buckle together, with potentially catastrophic consequences. According to the Federal Railroad Administration's Office of Safety Analysis, there are over 1,200 train derailments every year in the United States, an impressive 44.9% of which are directly caused by track failure, track buckling, and related defects. Countries with regular hot weather combat this phenomenon by pre-stressing their steel rails so that they can better withstand temperature changes without curving. This involves using hydraulic tensors to thoroughly stretch the steel rails prior to their installation. Since the steel rail tracks are tightly bolted down during installation rather than continuously welding them together when damages occur, short gaps are left between the rail joints. This allows room for potential thermal expansion and contraction so that the rail does not push or pull against itself at the joints and put pressure on the ballasts, ties, and anchors that hold it to the ground. Tracks in particularly sunny areas are also painted white, which reduces their heat absorption by around 5 to 10 degrees compared to non-painted tracks. The heat caused by the friction from fast-moving trains over a track can also trigger buckling, which means that in hot weather, many train operators implement speed limits on their services, often causing delays. Yet, despite precautionary measures, buckled railroad tracks and related derailments are a problem that costs the U.S. railway industry around $17 million in 2002 alone, with 38 derailments registered. The problem is further compounded by the growing size and weight of rail cars, which cause the tracks below them to degrade at a faster rate and become more prone to buckling. The lifespan of a line of railroad tracks averages 50 to 60 years, depending on its annual freight transportation volume and other factors. A track that regularly comes into contact with moisture will erode faster, whilst a straight piece of track can last much longer. When a line of buckled track is not quickly repaired, it's not passable at normal speed and could easily cause a train to derail. This will lead to long delays for passengers and immense losses for the railway companies. But there are many incidents of buckled tracks that remain in operation despite their potentially deadly flaws. They are known as sun kinks within the industry. This is more common on freight or cargo train lines where they're able to slow to a crawl as they pass the defective section. Of course, the worst-case scenario is when a track exposed to excessive heat buckles too rapidly within a short period of time. To combat this eventuality, the United States Texas A&M Transportation Institute has developed computational algorithms to help predict when lateral rail buckling may happen. Many train operators also use temperature probes along the track so they can monitor when a track is getting dangerously hot. According to Britain's Network Rail, in direct sunshine, railway tracks can become 20 degrees Celsius hotter than the surrounding air temperature. A track can operate in surrounding air temperatures of up to 30 degrees in the summer, with the steel rails themselves reaching 46 degrees at such times. This track temperature limit is usually much hotter in countries that experience regular hot spells. Rail track replacement is crucial because once a rail track buckles, it loses its integrity and cannot simply be straightened back into position. Up until the mid-1900s, replacing tracks was a laborious task that required a large workforce who manually laid the rails and sleepers using winches. Now, the railway track laying and maintenance sector features amongst the most high-tech in the entire transportation industry, with tracks laid by specialized road rail vehicles such as the Placer and Tourer RUS 1000. This is a massive 560-foot mobile rail track assembly line that simultaneously renews and replaces the track's sleepers, rail, and ballast in just a single pass. The machine picks up the old rail, disassembling it and passing it along the sides of the vehicle whilst laying a new track. During the process, the sleepers under the rail are replaced at a rate of 10 per minute. An excavating chain is used to remove the old ballast, which is transferred to the screening car for cleaning before being replaced along with the new ballast. This ballast is then compacted by the vehicle's tamping unit so that it acts as a steady bedrock for the tracks to sit on. During the replacement process, the machine also continuously sprays water to minimize dust. Modern maintenance machines like these have cut down the need for stringent manual labor, improved safety, and reduced delays by offering a one-stop maintenance solution that can repair and replace up to 1.2 miles of track per day. Further advancements are set to come, with the UK's University of Huddersfield researching the future of robotic maintenance on railways. However, not all train operators can finance such state-of-the-art automated machines or robotics, with some still relying on workers to operate smaller specialized road rail vehicles to complete track replacement in stages, a process that takes around 5 times longer, along with risks of injuries that are totally absent with automation. It is, however, too early to say at what costs these new technologies will come. On average, it costs between $1 million to $2 million to construct just 1 mile of rail sidings. The 2021 report card for America's infrastructure found that of the $700 billion spent over the last 40 years by private railroads to develop and maintain the current infrastructure, $24.9 billion was spent in 2018 alone, averaging $260,000 per track mile. With the rapid technological advancements in the sector, it's hard to tell what ingenious machines will be repairing our tracks moving forward, and at what cost. That's the end of today's feature on The Frame. Subscribe to the channel to catch us on the next video. See you next time!